Welcome to today's Math Happy Hour. Today's topic is going to be factoring. Factoring is very important for, for many of the upcoming courses. For example, if you're taking the NCBN 0114 and 0314, right, it goes to 1314. So here on the right are the courses that you have to do factoring in. For example, the pre-cal 1, the pre-cal 2, calculus 1, 2, linear algebra, and differential equations. If you're going like for business or accounting, then you're going to go this route, the 1324 and the 1325. And all these courses require factoring. As an instructor, I've been teaching the upper level courses all the way to differential equations, and to me it's always like what's the right word to say? It's disturbing when students actually are taking say Cal 2 or differential equations and they don't know how to factor. So something went wrong on their journey, but hopefully this workshop will be able to help you guys. Okay. So the purpose of factoring, quadratic expressions is to eventually lead to a method of solving a quadratic equation. The x-intercepts, solutions, zeros, and roots, it all means the same thing, finding the intercepts. And here's like an illustration on a graph of what the intercepts are. For example, where the graph crosses the x-intercepts is -4, 0, and 2, 0. And here's, right, so all those mean the same thing. I repeat, the x-intercepts, solutions, zeros, roots, they all mean the same thing. And here's the equation for this particular graph here. Okay, so the intercepts are going to be -4 and 2. Okay, now here are like real life examples of quadratic functions here. You see, for example, here's a bridge, right? So here are like the x-intercepts. Also here are like two or three parabolas, and here are many parabolas. So all these are examples of real life when the quadratic equations are used. Now, in my class, I let students use this factoring sheet. Okay, the factoring steps are like it's like a roadmap on how to factor. Because at times, students might say, Mr. Isasi, well, when do I stop? This factoring steps, will let you know when to stop because you cannot go any further. And here on the right is a factor sheet. I let my students use use both of these handouts, but not for the exams, only for them to have a better understanding. There's many instructors that they don't like for the students to use a factor sheet, but I just use them. They don't use them for the homework and also in class, but not for the exams. Okay, so in today's workshop, I'm going to go over all these steps. like in detail, from step 1, which is a GCF, and then step 2 is determine the number of terms. And note, make sure that the terms are in order. If not, rewrite them in order from the highest degree to the smallest degree. And then if it's 2 terms, either it's going to be perfect squares or perfect cubes. And here are the examples that I'm going to go over. Okay, for example, I'm going to go over the difference of 2 perfect squares. And if it's a plus, it's going to be prime. And for the perfect cubes, this is the difference of 2 perfect cubes and the sum of 2 perfect cubes. Then if it's 3 terms, it's going to, I call it the easy factoring because it's easier than, the number 2 here. And number 2, I'm going to do it by grouping. There's always different ways to factor, okay? But this is what I use, and I found out by students, they tell me that this is the easiest way to actually, to factor. And if it's 4 terms, I'm going to do it by grouping. Okay, and I repeat, many instructors use different methods, and also if you go to Google, they all have different methods to factor. But in my opinion, as an instructor, the students have told me that this handout is very, very useful and is very, very, very easy to use. Okay, that's what the students tell me. And if you want these copies at the end of the workshop, let me know, and I can send them to you. Okay, now again, these are the factoring steps, what I went over in the previous slide. Now, this is a vocabulary that students must be aware of. Quadratic expression is an expression involving a square term. If you notice, there's no equal sign because if it's an equal sign, it's going to be an equation. So an expression means there's no equal sign. Examples, x squared minus x minus 12, x squared minus 4, And negative 3x squared minus 4x minus 2 are all expressions or examples of expressions or quadratic expressions. Now factors, what are factors? Factors are numbers multiplied together to get another number. Example, what are the factors of 12? It's just saying, how can we get 12? 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 is 1, 2, 3, 4, 6, and 12. These are called factors. Example 2, what are the factors of 20? 1 times 20, 2 times 10, and 4 times 5. So it was going to be 1, 2, 4, 5, 10, and 20 are the factors of 20. Now comes the greatest common factor. This is like step number 1 on the handout that I gave on the steps to factor. The greatest common factor is a GCF, right? The GCF of a set of numbers is the largest factor that all numbers share. Or in other words, is the numbers that they have in common, the biggest number they have in common. Example, what is the GCF of 12 and 20? If you notice, those are the factors that we have here on top, 12 and 20. Remember, the factors of 12 is 1, 2, 3, 4, 6, 12, and we got it from up here in blue. And the factors of 20 are the ones over here, right, in green. It's 1, 2, 4, 5, 10, and 20. So what do they have in common? The 1s, the 2s, and the 4s. So the GCF is going to be 4, which is the greatest common factor. Okay, now, here's where I let my students use a factor sheet. And again, this factor sheet is very useful for students that have been out of school for a long time. Because at times students, they don't know how to do certain stuff because they've been out of school for a while. So this is like a comfort sheet, for them. And here's how we use it. Example 1, right? These are the same factors as before. Of 12 is 1, 2, 3, 4, 6, and 12. And 20 was 1, 2, 4, 5, 10, and 20. So here's how the factor sheet works, right? The GCF was 4. So how does the factor sheet work, right? So we're going to go to 12. There's 12. So I'm going to put it here on the right. There's my 12. Then my 20, right, is here at the corner here. So I'm going to put it here right next to it. So right away, it's obvious that the highest number they have in common is my 4. You see, so without actually listing the factors, you'll be able to get them here. And I repeat, every instructor is different. Some instructors let you use a factor sheet, and some don't. Okay, but it's up to the instructor. But in a way, if you need a factor sheet, like I said, I can email it to you, and you can use it like for practice at your house. So the GCF is the 4. Here's how we use the factor sheet. The answer is 4. Okay, now let's start with with the first step with the GCF, right? So this is the first step on the factoring steps. The greatest factor to factor out. Okay, let's do an example on number 1 here. Okay, what is the GCF of 20 and 30? Right, so we find the factors of 20. 1 times 20, 2 times 10, and 4 times 5. So these are the factors of 20. Factors of 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So these are the factors of 30. So what do they have in common, right? They have in common a 1, a 2, and a 10. What's the highest factor? Is going to be 10. So my GCF between 20 and 30 is 10. Now, in math, there's always also, variables, right? Or the letters in math are called variables. So a quick example of the GCF of the variables. For example, what's the GCF of x squared and x cubed? So x squared is the same thing as x times x. And x cubed is the same thing as x times x times x. So how many do they have in common, right? They have in common 2 x's, right? There's 1 and there's 2. But here, guys, you don't add them, you multiply them. So the GCF of x squared and x cubed is going to be x squared. And here's like an observation or like a hint. If both terms have the same variable, right? For example, here they both have the same variable, which is x. The variable with the smallest degree is a GCF. The smallest degree means the one with the least power, or the smallest power. So the answer will be x squared. Now here's how step one number one works. What's the GCF, right, between 30x squared plus 20x cubed? Okay, so we already know that the factors of, the GCF of 20 and 30, right, it was up here, right, so we did that. So the GCF of 30 and 20 is going to be 10. And the GCF of the two variables, the x squared and the x cubed, is going to be x squared. So we're going to factor out the 10x squared. Right, so we're going to factor out, so what's left? So here you can either multiply or divide. I like to multiply. For example, I'll say 10 times what will give me 30, right? So the answer is 3. We have x squared, we need x squared. Do we need more x's? No. So the x's are good there. So we bring down the plus. Or if you want, you can even divide. What's 20x cubed divided by 10x squared? The answer will be 2x. And you can always check your work by using the distributive property. Example, 10x squared times 3 will give me 30x squared. 10x squared times 2x will give me 20x cubed. So I know this is a correct way to factor out the GCF. Now factor out GCF continues. For example here, right? What's the GCF between, let me go back real quick. What's the GCF between x times 2x minus 5 plus 2 times 2x minus 5? So here, guys, these are two terms, right? We have one term on the left and one term on the right. So like I tell my students, the 2x minus 5 is called a binomial. So both terms have the binomial 2x minus 5, right, in common. So that's my GCF. If you factor it out, what's left, right? So if you take out the 2x minus 5, what's left? The x plus 2. This is how you factor these type of problems here. And this is crucial when you're going to be factoring by grouping, okay, which we'll get there later on this PowerPoint. So my answer will be 2x minus 5 times x plus 2. Again, the example is crucial for factoring polynomial with 4 terms. Now let's do another example. Now we're going to go and right from the steps to factor, we're going to go to if you have 4 terms. If you have 4 terms, we're going to do it by grouping. Okay, now this is an example how the book does it, and a lot of instructors do it too. Okay, but I have a modified way, which I'm going to show you after this one here. The book says to group them in 2 pairs, right? Because they're 4 terms. So let's call this group 1, and we'll call this group 2, the 3x plus 12. So first, I'm going to factor out the GCF, from group 1. So we're going to be doing what we just did at the beginning, right? Where we factor out the factors of numbers with variables. So for example, right, we're going to factor out group 1. Group 1 has a 2, right? The factors of 2 is 1 and 2. The factors of 8 is 1, 2, 4, and 8. So what's the highest number they have in common? Well, the GCF is going to be 2. Now for the variables, right, we have x squared and we have x. Remember the observation? If they both have the same variable, it's going to be the one with the smallest degree, which is 1. So that's why it's going to be x. So the GCF of group 1 is going to be 2x. Okay? Now, I'm going to go here, guys, and I'm going to factor out the 2x. So if I do that, what's left? X plus 4. Now, we're going to do group 2. Right? We did a plus, and we're going to do group 2 now. Here on the right is going to be group 2. Between 3 and 12, the GCF is going to be, the factors are going to be 1 and 3 for the 3, and for the 12, it's going to be 1, 2, 3, 4, 6, and 12. And again, how do we get those factors? Because 1 times 12 will give me 12, 2 times 6 will give me 12, and 3 times 4 will give me 12. So the highest factor, right, is going to be 3. Now, do both terms have an x, a variable? No, they don't, right? So for that one, they don't have nothing in common. It'll just be the 3. So then it's going to be 3. So what's left? If I factor out the 3, it's going to be x plus 4. If you notice, both group 1 and group 2 have the same, the factor that was left was x plus 4. Okay. So the answer, right? And then you ask yourself, what do they both terms have in common? The 2x plus 4 plus 3x plus 4 will be the x plus 4. So then what's left? The 2x plus 3 is left. So that's my solution, guys. X plus 4, 2x plus 3. Now again, this step here, guys, is step 2C when you have 4 terms. Okay. Determine, after you do step 1, the GCF, then you go to step 2, determine the number of terms. So right now, guys, right, it was going to be 4 terms. That's why we're going to be grouping, doing examples with 4 terms. Now, here's my way that I do it, guys, and I believe, Swiss have told me that it's easier. Okay, so I'm going to use another way. Okay, for example, say that we have 2x squared minus 5x plus 4x minus 10. So how I do it, guys, I'm going to factor out by grouping. I'm going to factor out the first 2 terms. Find the GCF of the first two terms, which is 2x squared minus 5x. Right? What do they have in common with the numbers? Right? So there's nothing, right? It's going to be 1, but if it's 1, it doesn't really count. With the variables, it's going to be x. Right? So that's it. So if I factor it out, next here on the first 2 terms, what's left? 2x minus 5. Okay, now this is my method of I'm showing the students how to work it out this way. So what you have here, 2x minus 5, just automatically put it on the right side, 2x minus 5. The sign, you bring it down. Then you can ask yourself, because something has to go here. A number has to go here, either a 1 or some number has to go here. So you ask yourself, what number times 2 will give me 4? The answer is 2. And again, you can always check your work. For example, here on the left, x times 2x will give you 2x squared. X times negative 5 will give you negative 5x. Here on the right, 2 times 2x will give me 4x. And 2 times negative 5 will give me negative 10. So I know I'm in the right path. Now, the GCF, right, between those 2 terms will be 2x minus 5. So if I factor it out, what's left? It will be the x plus 2. Okay. And again, I modify a little from the textbook. The binomial that is left after factoring out the GCF on the first 2 terms, right, which I'm talking about this one, will always be the same binomial on the right side if it can be factored by grouping. You see, so that's what it means here. Whatever you factor out here, right, whatever's left, all you do is automatically put it on the right and then just follow the steps as I just explained. Okay, now comes factor by grouping again. Okay, how about this one here? Okay, so we have 4 terms, so I'm going to factor by grouping. What does 3x squared minus 6x have in common, or the GCF? From the 3 and the 6, right, we know it's going to be 3. And actually, you can get those by looking at the factor sheet. Just go to the 3 and the 6, and you're going to notice that the highest number they have in common will be the 3. And for the x's, right, they have x squared, and we have an x, so it's going to be 3x. So if you take out the 3x or you factor it out, what's left? Will be left x minus 2. Now what you have on the left, right? You put in the right. The negative comes down, the sign. Now what number times x will give me 7x? So the answer is 7. And again, you can check your work. Negative 7 times x will give me negative 7x. Negative 7 times negative 2 will give me a positive 14. So I know I'm on the right track. Now, the GCF between these 2 terms, right, is going to be the x minus 2. If you factor it out, what's left? The 3x minus 7. So let me go back. So this is my solution, guys. X minus 2 times 3x minus 7. Hey guys, if you have any questions as I'm doing this presentation, just even though I'm sharing my screen, because I have another computer here on my left, and I can see if you have any questions, just go in the chat, raise your hand up, and perhaps I can give you some clarification. Now let's do, right, so now let's continue. I've done step 1, I've done step 2, and I've done step 2C. Now let's do 2A, if 2 terms. Right, if 2 terms, it can be either perfect squares, right? If you notice, only when it's minus, you'll be able to do x minus y and x plus y. If it's plus, it's going to be prime, which means it cannot be factored. So let's do these type of examples now. Okay, now here, guys, right? So again, these are the two ways to factor. So here, guys, you have to know perfect squares. For example, what's a perfect square? Example, x to the fourth is a perfect square. Why? Because x squared times x squared will give me x to the fourth. X squared is also a perfect square because x times x will give me x squared. And then 1's a perfect square because 1 times 1 will give me 1 squared. 4 is a perfect square because 2 times 2 will give me 4. 9 is a perfect square because 3 times 3 will give me 9. 16 is a perfect square because 4 times 4 will give me 16. And I believe after that, but you got the picture, right? These are all called perfect squares. These are called perfect squares. The x squared minus y squared are also called perfect squares. So x squared minus 1, the answer will be x minus 1 and x plus 1, following the formula here. Difference of two perfect squares. X squared minus 4 is going to be x minus 2 and x plus 2. X squared minus 9 will be x minus 3 and x plus 3. And what's x squared minus 49? It's going to give us x minus 7 and x plus 7. X squared minus 81 is going to give us x plus 9, x minus, here, guys, if you notice, I changed the signs, right? I put the plus first and the minus second. Here, it doesn't matter, guys. As long as you have a positive and a negative with a perfect square of x and a perfect square of 81, which is 9, it's okay to have the signs reversed. It doesn't matter. Now, x squared minus 100 is going to give you x minus 10 and x plus 10. How about this one here? 25x squared minus 36y squared. Right, we know that 25 is a perfect square because 5 times 5 will give me 25. And we know that x squared is also a perfect square. And also 36 is a perfect square because 6 times 6 will give me 36. So here, guys, this will give us 5x minus 6y and 5x plus 6y. How about x squared minus plus 36? This is tricky, guys, because remember, if it's plus, it means it cannot be factored. So the answer is prime, right? How about x to the fourth minus 16? Here, right, x to the fourth is also a perfect square because here it is on top here. X to the fourth is the same thing as x squared times x squared. And 6 is a perfect square because it's 4 times 4 will give me 16. So this will give us x squared minus 4 and x squared plus 4. Now, if you notice, the x squared plus 4 cannot be factored any further. But the x squared minus 4 can also be factored because x squared is a perfect square and 4 is a perfect square. So this will give us x minus 2, x plus 2, and we bring down the x squared plus 4. This is crucial, like for students taking the 1314 and Math 1314, because I believe in chapter 2 you'll be finding the zeros, and this is very, very common use of finding the solutions of perfect squares. So this should be kind of simple, guys, right? If you know what perfect squares are. Now, let's go down to, right, so we did the perfect squares. How about the perfect cubes? Hey, guys, perfect cubes, those are already seen. When you see them, you see them rarely in Cal 1 and also Math 1325 and very briefly in pre-Cal 1, just briefly. But I'm still going to go over them. Okay, so these are the formulas, right, for the difference of two perfect cubes. We have x cubed minus y cubed is equal to x minus y, parentheses, x squared plus xy plus y squared. For the sum, the difference of the sum of three, the sum of perfect cubes is going to be x cubed plus y cubed is equal to x plus y, and then x squared minus xy plus y squared. These are easy to remember, the formulas. If you notice, you have x and y at the same places. The only difference, if it's a difference, the first one's minus and the rest are plus. If it's plus, if it's the sum, the first sign is plus, the second is minus, and the rest are plus. Okay, now, what are perfect cubes? perfect cubes is 6 to the 6, x to the 6th power are perfect cubes. Why? Because x squared times x squared times x squared will give me x to the 6th power. So x cubed is a perfect cube because x times x times x will give me x cubed. 1's a perfect cube because 1 times 1 times 1 will give me 1. 8's a perfect cube because 2 times 2 times 2 will give me 8, and so forth. Try to remember or to memorize at least up to 8 to 125. Okay, because it's rarely something higher than 125 for the perfect cubes. Are used on the upper level courses. Maybe in the remedial course in the 0314 or the 0324, maybe they have some of those, but in the upper level courses, they're really seen. Okay, now so how do we use the formula here, guys, to solve, for example, to simplify or factor x cubed plus 125? So here, guys, you're going to be asking yourself, is 125 a perfect cube? Yeah, yes, it is, right? It's 5 cubed. So I'm going to rewrite this and use the formula number 2, which is a sum, right? So is it sum or difference? So it's going to be the sum. So this is a formula that I'll be using. Now here, I have to rewrite x cubed plus 125 to fit this form here. So 125 is equivalent to 5 cubed. So everywhere I see an x, I'm going to put an x. Everywhere I see a y, I'm going to put a 5, right? There are the signs and the parentheses. So the x is just x. The y will be 5. X squared will just give us x squared. Xy will give us x times 5 will give us 5x. And y squared will give us 5 squared. Right? And now we simplify it. So it's going to give us x plus 5 times x squared minus 5x plus 25. Okay, let's do another one. Now it's a sum. Let's do the difference. So this is going to be right number. Is it 1 or 2? Right? It's going to be number 1. So this is a formula that I'll be using. Now, but this one here is a little bit more trickier. Something like this you will not see in the upper level courses at all. I haven't run into something like this. Okay, with numbers in front and then with the variables and so forth. This is rarely seen. But anyway, that way you have a better understanding how to work these. So we have to rewrite it, right? So 3x cubed is equivalent to 27x cubed. And 4y cubed is equivalent to 64y cubed. So everywhere I see an x, I'm going to put 3x. Everywhere we see a y, I'm going to put 4y. Okay, so x is going to be 3x. The y, right, we're going to put 4y. X squared, we're going to put 3x. Right, for the x, we're going to put 3x. And for the y, we're going to put 4y. And for the y squared, we're going to put 4y also there. Now, let's simplify. This gives us 3x minus 4, minus 4y. 3x squared will give us 9x squared. 3x times 4y will give us 12xy. And 4y squared will give us 16y squared. So this is how we do factoring the difference in the sum of two perfect cubes. Now comes 2b here, right? If we have 3 terms. If it's 3 terms, right? I call it the easy factoring, but also this one is a little bit modified than a textbook. But first, let me show you how most instructors cover this section here with x squared plus bx plus c. Okay, here's how most instructors do it, and also the textbook times does it. So I'm going to show you 2 ways, and then this way you guys can decide what's easier for you. It's not about the instructors, it's not about nobody, it's about you guys, for the students. Okay, that's why I like to give options to my students. This way they have what choice to use, what's easier for them. Okay, now. So here, guys, we're going to get the factors, all right, of negative 20. Again, this is the way the textbook explains it. How can we get negative 20? Negative 1 times 20. 1 times negative 20. Negative 2 times 10. 2 times negative 10. Negative 4 times 5. and 4 times negative 5. Right, so if we add these, what's negative 1 plus 20 is going to give us 19. What's 1 minus 20 is going to give us negative 19. Negative 2 plus 10 will give us 8. 2 minus 10 will give us negative 8. And negative 4 plus 5 will give us 1. And 4 minus 5 will give us negative 1. Okay, so then, right, where's the match here, right? So we're trying to find a match. The match here, right, is saying that it's 1, positive 1. So this is my match, negative 4 and 5. Which means it's going to be x plus 5 and x minus 4. That's your answer. In my opinion, this way can be a little bit tedious because what happens if the constant term, the c here, is a big number like say 64 or 96? Imagine all the factors you're going to get. And also, as my experience, there's some students that come to college, right out of high school, and they don't know how to add and subtract integers. So right away, they're off to a bad start. Okay, but I mean that's why the factor sheet will actually help them. Okay, and again, this is for the students that are struggling with factors, so you can use the factor sheet. But try to memorize or try to understand it this way because most instructors will not actually use it on the exam. Okay, now let's do another example this way, and then I'm going to show you the way I have modified it. Here's another example. Okay, again, this is the way the book shows you. How can we get, oh, this is supposed to be positive 30 here. My bad, it's because I was doing the PowerPoint this morning. It's supposed to be positive 30, okay? Because it's 30 there. I repeat, this is supposed to be positive 30, right? Because that's my constant. So how can we get 30? Negative 1 times negative 30. 1 times 30. Negative 2 times negative 15. 2 times 15. Negative 3 times negative 10. 3 times 10. Negative 5 times negative 6. And positive 5 times positive 6. Right, so now we add them. Negative 31. 31. Negative 17. 17. Negative 13. Positive 13. Negative 11. And positive 11. Okay, so the match, right, is negative 11. So this is my match here, negative 5 and negative 6 is my match. Which means, right, it's going to be x minus 5 and x minus 6. Again, this is the way the book shows you, and also how many instructors also teach this type of factoring. Now, I'm going to do it my modified version of factoring, okay? Okay, it's going to be like this. I call it the easy factoring because it's easier than when you have a number here in front of the x squared. Okay, here's how I do it, okay? If you have it this way, it's going to be two binomials. Now, here are the rules. Because the c is called the constant term. The bx term is called the bx term. So the constant term is very important factoring this way. If the constant term c, right, if the c is positive, the signs will be the same. If the constant term c is negative, or if c is negative, the signs are going to be different. Okay? And for the students that are here, guys, that are from my classes, okay, this is the way I'm going to show you guys, okay? Because I see a lot of my students here in this. I mean, they're in the participants. So now, so the first thing that you have to know, guys, is, I mean, are the signs the same or different? That's all you have to say. For example, example 1, we have x squared minus 10x plus 24. So right away, guys, your eyes should focus here on the constant term, on the plus, right? So if it's plus, they're going to be the same. Number 2, x squared minus 7x minus 30. The constant term is negative, so they're going to be different. Number 3, right? The constant term is negative on the x squared plus x minus 20 is negative, so it's going to be different. Number 4, x squared plus 8x plus 15, the constant term, right? The 15 is positive, so it's going to be the same. The same means it's going to be the sum of the factors must equal to the bx term. If it's different, it's going to be the difference of the factors must equal to the bx term, right, and so forth. Now, this is the only way it can be. It can only be in 4 ways, I mean, the signs. So let me show you all these 4 examples, okay? Remember, example number 1, same signs, right? So like I tell my students, you always bring the sign down because this tells you what the signs are going to be. If that's minus, right? So, and they're the same sign, they're both going to be minus. Now I'm going to get the factors of 24. How can I get 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Right, also this sign tells you what we do here, right? Remember, guys, the same signs, we're going to add them, right? Because it's a sum of the factors that will give me, that will give me the bx term. So this sign also tells you what we do here, guys. This will be easier than, than with words. It means we're going to add them. And again, when I explain this, I don't show you all this stuff here, guys. This is just for the concept, okay? I'll go straight from here. The last two examples, I'm going to show you how I do it in class. But for now, I have to show, teach the concept, but here's what's taking place. So what's 1 plus 24? 25. 2 plus 12? 14. 3 plus 8? 11. 4 plus 6? 10. Where's my match? Here's my match, right? So the answer will be -6 and -4, which will give me the -10 when you add them. Right? So these are my solutions, -6 and -4. Example number 2. Right? We know it's going to be different signs, right? So again, the first time we bring it down. So if it's minus, there has to be a plus because negative times a positive will give me a negative. Next step, how can we get -30 or 30? Factors of 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And also this sign tells us what we do here. We're going to subtract. Again, this is also just for the concept here. So what's 30 minus 1? 29. 15 minus 2? 13. 10 minus 3 will give us 7. 6 minus 5 will give us 1, right? So where's my match? My match is 7, right? It's got to be a 7. So the 3 and the 10 are my match. So the 10 has to be negative, right? Because -10 plus 3 will give me the -7. If it was a positive 7, then it will be the 10 minus 3. But since it's negative, it's going to be -10x plus 3. So there's my match. Okay, now, the sign of the bx term determines the largest factor. If the sign of the bx term is brought down, then the largest factor always goes first. Hey guys, this idea about the first time bringing it down, I got it from a student. Because every time that I teach, I tell my students, hey guys, if you have a different way or a better way to explain than me, let me know, and then I'll use your way. But who gets to vote if it's easier than my way? The students vote. They vote, and sure enough, when I was explaining this topic back when I was teaching 0305, a student came up with the idea, and she mentioned, Mr. Sassi, I get confused. I said, when? About what sign goes first and all that. So she said, I came with an idea. And then she said, this, and I was bringing it down. I said, why? Because according to the rules, this sign determines the biggest factor. But if I bring it down, I don't have to worry about that. I just put the bigger number first. Okay. So then she mentioned it to the class, and sure enough, the class voted that was easier than my way. Because in the past, I would say signs going to be different. It can be minus and plus or plus and minus. But the class agreed. So after that, I always like to give credit because that wasn't my idea. It was a student's idea. But now, since it's easier for students, I like to use her idea because I believe students, when the students understand it, most of the students actually like it when other students come up with ideas because they can relate to them. Okay, so this method, I got it from a student. Now here's how it's really done. Okay, without all the explanation. Example: x squared plus x minus 20, right? So we're going to subtract, right? The difference. The sign comes down. Right, so it's going to be different signs. It's going to be plus and a minus. How can I get 20? 1 times 20, 2 times 10, and 4 times 5. Right, so it's going to be what, right? And also this sign tells me what we do here, right? So it's going to be minus. There'll be 19, there'll be 8, and there'll be 1. My match is the 1, right? So right away, I know that the 5 goes there, and the 4 goes there. That's how you factor. And this is the way I'll show you guys in class. But I don't do all this, guys. I just put the arrow down here, which means we're going to subtract. Now how about x squared plus 8x plus 15? Right? We're going to add them. Right? We bring the sign down. We know signs are going to be the same, so they're going to be positive. We're going to get the factors of 15. 1 times 15 and 3 times 5, right? We're going to add them. The 1 plus 15 will give us 16. 3 plus 5 will give us 8. My match is 8, right? So we're going to put the 5 first and the 3 first and the 3 second. It doesn't matter when the signs are the same. But if I tell students that it matters under a certain condition and it doesn't matter under another condition, they're gonna get confused. So I always tell them, you always put if you bring the sign down, you always put the bigger factor first. This way to avoid confusion. Okay. Now comes the last part of this presentation, which is I believe this is the hardest one, which is by grouping. Okay, and here, guys, is like a roadmap of how to get it. You see, for example, what does a 3, 4, 2 in factor means? That means that you're going to start with 3 terms. And then you're going to go to 4 terms and then 2 terms and then the answer, the factor. Example. You see here, guys, how you approach something like this, right? You will start with step 1. What's my GCF? What do they have in common? Nothing. Step 2, number of terms. Oh, they have 3. Right? If it's 3 terms, it's either the easy factoring or by grouping. This is by grouping because we have a number, a coefficient in front of the x squared. That's why that's like my A. So here it tells you what to do. I'm going to multiply the first term times the last term, which will give us 30. Now we're going to get the factors of 30. How can we get 30? 1 times 30, 2 times 15, 3 times 10, 5 times 6. Right? So we're going to add them. So 1 plus 30, right? It gives us 31, 17, 13, and 11. Right? So now the match, right, is 11, right? Because the BX term is 11. So I'm going to use the 5 and the 6 to make up the 11. So 6x plus 5x give me 11x. So I'm going to go back to the problem here. The two corner, the first and the last one, you keep it the same. I'm going to replace the 6x plus 5x for the 11x. You see, we have started with 3 terms. Now comes the 4 terms, right? Now we're going to do it by grouping. How we did, I believe, towards the beginning of the presentation. You can ask yourself, what does 3x squared plus 6x have in common? Well, the GCF is going to be 3x. If you factor that 3x, what's left? The x plus 2. Remember, what you put on the left, you also put on the right. The sign comes down, the plus. 1 number times x will give me 5x. The answer is 5. Right? You see I went from 3 terms to 4 terms. Now 2 terms. 1, 2. Now comes my answer. What they have in common, the left and the right, is x plus 2. What's left? The 3x plus 5. Factor. Here's how you factor these type of problems. Let's do one more. Again, now we have 2x squared minus 3x minus 9. Hey guys, I use small numbers because most of the times when you get to pre-cal, to calculus 1, calculus 2, differential equations, linear algebra, there's no big numbers, guys. They're always kind of small. That's why I like to use small numbers for the A, the B, and the C. So here, guys, we're going to multiply the 2 and the 9, right, which will give us 18. How can I get 18? 1 times 18, 2 times 9, 3 times 6. Right, that means we're going to subtract them. What's 18 minus 1? 17. 9 minus 2, 7. 6 minus 3 will give us 3. Right, my match is 3, right? Hey guys, if the match wasn't here, it means it cannot be factored. Simple as that. So we know that 3 and the 6 is my match. Since it's negative 3x, right? The 6 has to be has to be negative 6x plus 3x, because this will give me the negative 3x. So now I'm going to repeat the process as a previous slide. Right? The first and the last term, they say the same. I'm going to replace the negative 3x with negative 6x plus 3. Now we have 4 terms. Now the first 2 terms, you're going to get the GCF. What does 2x squared minus 6x have in common? The answer will be 2x. What's left? X minus 3. And again, like before, what you have on the left, you put on the right. The plus sign comes down. Then you can ask yourself, what number times x will give me 3x? The answer is 3. Now, what do both two terms have in common? Will be the x minus 3.
Mr. Isasi, Sebastian has a question.
Okay. Sebastian, how can I help you? Sebastian, you want to put it on the chat, or you want to get into the mic? I think we lost him, right?
I think it was an error. He raised his hand and then lowered it, Mr. Isasi. So if he puts it on the chat, I'll let you know. You can continue, sir.
Okay. And maybe towards the end, because I'm almost done. Towards the end, maybe I can go back and explain it to him.
No worries. I'll let you know. Thank you, sir.
Okay. So here, guys, right? They have in common the x minus 3, so I'm going to factor that out. So what's left? The 2x plus 3. This is my answer, guys, factor. Hey, guys, here's how you factor it. I just showed you an example of every single way to factor. Okay? And again, if you want a copy of the factor sheet with the steps to factor, please let me know, and I'll email it to you. So, hey, guys, why is it important again? And again, guys, every semester, when I teach these type of classes, like the pre-cal, the 1324, the calculus, and the differential equations, I just can't believe that some students, they don't know how to factor. And maybe it's not their fault. Maybe they something went wrong, but it's not us as instructors to judge you guys. It's us to help you to find where you have any issues, so that way we can correct that issue before you keep moving on. Okay, guys, and the instructors and myself, we're here to help you guys. The tutors. So for other students, guys, you're not here on your own. We're here to help you. We got your back. Anyway, guys, problems to factor, right? Example 1324, and I got this from the book, section 1.7, quadratic equations, page 58, using factoring to solve each equation, right? So these are the ones, right? You have to factor, right? The easy factoring by grouping, and this is two perfect squares. 1325, limits, page 569. Find the limit if it exists. Again, you have to factor. Right, to factor, to get to something, to get a limit. Math1314, find the zeros, 1.5, right? Page 56. All these came, I got, but there's more examples, but I just got those. What else? 2412, right? Solving trig functions. Right, so first, right, so the cosine, right, you convert it to 4x squared minus 1, and then afterwards, you substitute the x back to the cosine and then solve for the unit circle. Calculus 1, limits again. Limits in critical numbers. By taking the derivative. Calculus 2, find the area between two curves. Linear algebra and Math 1320 for the differential equations, right? Wasn't computing the eigenvalues, right? And also, guys, for differential equations, what we were doing last week, right? Finding the point, find the critical numbers, and if it's stable and semi-stable, right? So all that you have to know how to factor. And I believe that's it for this presentation, guys. I hope it was good. Good resources for you guys to use. And like I said, if you want the copy of the factor sheet, let me know and I can email it to you. Let me send it back to the host. Thank you, guys.
Hi there, Mr. Azasi. I got a question in the form of a private message. They said, okay, I don't know who to speak with, but I have some questions about where to review the video, and I would like to meet him to send me the factoring sheet. So to get the factoring sheet, do they just need to email you?
Yes, because I have it here in my USB. Or maybe, do you want me to send it to you, Patricia? Or you know what? Just get my email. Hey, guys, I'm going to put my email on the chat, and you guys send me an email, and I'll respond to you right now because I'm here in my office. Okay, so let me go to the chat, and this way. And if you're ever here in Trans Mountain, guys, and you need help, hook me up. I'll hook you up. Just come to my office, 1107, and I'll help you. Okay, but anyway, here's my my email address.
He's going to put his email in the chat, and then right above it in Hema's last post, she has a link for previously recorded sessions. That is our playlist. All the videos, even the video you see today, sometime this afternoon will be uploaded to that playlist, and y'all are able to view it then. Oh, thank you, Hema, for posting again. And so you have Mr. Zossi's email, so you can get the factoring sheet and the link for the playlist. Is there any other questions for Mr. Zossi before I hand it over to Pablo?
Also, Patricia, can I say something real quick?
Yes, sir.
Hey guys, for the students that need help, I also do Sunday numbers. Come to Trans Mountain from 9 to 1, but it depends on your course. For example, for Math 1314 and 1324, it's from 9 to 10, and then from 10 to 11 it's for 2412. Then from 11 to 12, it's the calculus and the business math, the 1325, and then differential equations is from 12 to 1. Come by, guys, because they gave me 2 tutors. I have 2 tutors with me that we can help you. I can help you with the exam reviews and stuff like that. Just hit me up on Sundays here at the Trans Mountain, room 1136. Thank you.
All right, thank you very much, Mr. Isasi. That was a wonderful presentation. Factoring, like you said, is very important. And so for those of you who joined us today, make sure that you did get your student ID number to Ms. Patricia to get credit for the points. And then for next week on the Happy Math Hour, February 14th, Valentine's Day, we will have Exam 1 review for Math 1314 and Math 1324. For student success topics next week, we will have the EPCC libraries, and later on today at 1 p.m. for the student success topics, we will have, where is it? Memory tricks at 1 p.m. Okay, I forgot about that, so I need to attend that. And, all of you have a wonderful weekend. Thank you very much. If there's no further questions, please sign out and have a great weekend. Thank you.